Boa tarde. Agora, hoje, vamos começar a segunda parte, o segundo dia do curso do professor Paul Perieschi, na Universidade Federal de Goiás. A primeira parte do curso é sobre a chalcones, químico preventivo, chemically preventive chalcones. En este momento eu vou passar a palavra para o professor Paul para começar a sua apresentação. You can begin.
Yeah.
Yes. Some problem? Your phone is not. Oh, okay. Now it's okay. Wait a please. Ora, a terceira parte do curso que está sendo ministrada pelo professor Paul Perieschi em nossa instituição, esta terceira parte tem a ver com químico preventivo chalcone. Agora, esta parte tem aproximadamente 45 minutos e quando estamos bem perto do final desta parte, eu vou disponibilizar o formulário de presença para aqui, tá bom? Okay.
So welcome to everybody today. As a continuation of the previous lecture of this series, today the today's lecture will be about the chemopreventive effects of chalcones, which is, in my opinion, is at least as important as their anti-cancer effects we discussed yesterday. Let's start the structure of the chalcones with the chalcones structure again, resembling that these natural products and their scientific analog and the synthetic analogs are composed of three structural units. Two aromatic rings noted as A and B, and an enone linker, a 3-carbon linker in a conjugated carbonyl and a carbon-carbon double bond. As it was discussed in the first part of the series, the most stable configuration of the non-specifically substituted chalcones are the E configuration concerning the carbon-carbon double bond, and the S-cis configuration concerning the sigma bond, which links together the carbon-oxygen and the carbon-carbon double bonds. In this introductory part, I wish to show some unsaturated carbonyl compounds which are found among the natural products and those which have proved biological activities. So, for example, among them you can see butane, chalcone derivatives, However, you can see among them prostaglandins as well, terpenoids and quinoidal compounds. And among the drugs, I think the most well-known small molecule or compound with unsaturated alpha-beta unsaturated carbonyl bond is the diuretics ethacrinic acid. Returning to chalcones and the biological effects of chalcones, today let's review the chemopreventive effects of the compounds. The chemopreventive effects of chalcones and, broadly speaking, flavonoids can be associated with 3-4 different pathways. One of them is the antioxidant effects. The second one, modulation of enzymes, which involved in activation and conjugation of carcinogens. So, for example, among them, we can find inhibition of cytochrome P450 enzymes, which are involved in activation of compounds to become carcinogenic electrophile, or introduction of enzymes which are involved in elimination of toxic electrophiles. Another important path of chemoreactive effects is inhibition of the steroid PI synthesis, resulting in aromatase inhibitors, and the anti-invasive effects of the compounds, which we call scientifically the anti-angiogenic effects of them. Chemoprevention. Chemoprevention is a definition which was first coined by Michael Sporn, and just recalling their original definition, chemoprevention is the use of pharmacologic or natural agents that inhibit development of invasive cancer, either by blocking the DNA damage that initiates carcinogenesis, or by arresting or reversing the procession of malignant cells in which such damage has already occurred. So, as we can see from this definition, different levels of chemoprevention can be distinguished. Among them, the so-called primary prevention seeks to prevent malignancies, cancers, in otherwise healthy population. The secondary prevention involves patients who have known pre-malignant lesions, utilizing medications to prevent the progression of these lesions to cancers. And the tertiary prevention focuses on the prevention of new cancers in patients cured of an initial cancer, or individuals who have been treated for pre-malignant lesions. As for the carcinogenesis, the program of the carcinogenesis, the program of the chemical carcinogenesis, is simplified in this chart. In the initial step is a somatic mutation of the normal cells, which followed by a second stage, which we call promotion, and the next one, which is progression. In the progression stage, up to the progression stage, the initial damage of the cells can be successfully treated. However, if the program goes into the next step, invasion and metastasis, the cure, the treatment of carcinogenic patients are much more complicated. Let's see what are the main mechanisms of chemoprevention, taking into consideration of the previously mentioned chart showing the progress of carcinogenesis, chemical carcinogenesis. So the normal cell is in the initiation step, is damaged by a carcinogenic event, initiating event, which can be an electrophilic chemical. However, it can be it can also be a virus, or it can be a electromagnetic radiation with proper energy. The initiated cells afterwards can undergo a second step, which called promotion, resulting in pre-neoplastic cells, and these pre-neoplastic cells is the stage which can be still successfully treated by the so-called chemopreventive agents. Depending on the mechanism of action and the target of the chemopreventive agents, we can distinguish blocking agents, which blocks the initiation, or we can distinguish suppressing agents that blocks the promotion. The promotion step followed by progression, yielding neoplastic cell, and metastasis, resulting in development of malignant tumors. We will see a lot of natural products that can be found, can act at the initial stage and in the progression stage. Among them, I could also mention curcumins, which are very similar structure to chalcones. However, as you can see, the non-steroidal anti-inflammatory drugs are also listed among both the initiation step prohibitions and the progression step prohibitors. Let's see some dietary phytochemicals that block, suppress the multi-stage carcinogenesis. So among them, as I mentioned here, we can see the cancer-blocking agents are the ellagic acid, the indole-3 carbinols, sulforaphines, and the flavonoids. And in this lecture, obviously, we are going to concentrate on flavonoids. As for the cancer-suppressing agents, it should be mentioned carotenoids, among them beta-carotene, I think the most known. However, we can listen here also genistein, resveratrol, capsaicin, just to mention the most important and most frequently eaten dietary phytochemicals. When we are talking about classifying the chemopreventive agents, of course, we can take into consideration different approaches to classify them. One of them is based on the progress of the carcinogenesis, and based on this, we can distinguish initiation preventing or blocking agents. We can distinguish apoptosis inducing agents, which force the initiated cells or the pre-neoplastic cells into apoptosis. Among them, you can see curcumin, the non-steroidal anti-inflammatory agents, genistein, the retinoids, tamoxifen, just to mention some known examples. Among the differentiation-inducing agents, we can list retinoids and vitamin D as a chemopreventive compounds. And as for the progression, proliferation blocking agents, you can see the cell proliferation inhibitors. Those were discussed in the previous lecture, and angiogenesis inhibitors, among which also there are several flavonoids. Another type of mechanism-based classification of chemopreventive agents are the immune system boosters. The immune system itself wears a separate lecture. So in this series of lectures, these type of chemopreventive agents will not be discussed in details. Another approach of classification of the chemopreventive agent is the chemistry-based classification, and taking into consideration the chemical reactions, the chemical mechanisms of the action of these compounds, we can distinguish three main groups, namely the antioxidants, inhibitors of metabolic activators, or inducers of metabolic detoxification pathways. Let's start with the antioxidant. Among the antioxidants, there is a wide range of small molecular compounds. Among them, we can mention vitamin E and vitamin C and reduced glutathione. There are some thiol compounds like lipoic acid. There are some quinones like Q10, selenium in forms of selenite itself is also can act as an antioxidant after intensive metabolic transformation of the original selenite structure. Plenty of phytochemicals belong to this class of chalcones, and not to mention the enzymes, which are also act as antioxidant in different ways that we will see in detail in the next few slides. The initial damage of the DNA can be of different origin. One of the most commonly known or most frequently mentioned state is the so-called oxidative stress, in which the redox equilibrium of the cell is destroyed, and as a result, several reactive oxygen and reactive nitrogen species are formed, which can direct threat of the DNA, the different part of the DNAs. Among the carcinogens, there are plenty of alkylating agents, some mycotoxins like aflatoxin B1, that's the most toxic mycotoxin. There are some environmental carcinogens like arsenic, which is very serious issue in particular part of the world where the flows, the rivers and other flows, water flows have got relatively higher arsenic content. The radiation is well known. The UV radiation is a well-known threat. Everybody knows it. In particular, in summer times, when the UVA and the UVB irradiation is generally higher than the average. The polycyclic aromatic hydrocarbons we were mentioned in the previous lecture. Among them, dimethylbenzanthracene is the compound that were mentioned yesterday. And there are some drugs which typically after metabolic transformations are converted into electrophilic species which can covalently modify the DNA structure, and the so-called N-nitroso compounds, which can be endogenous or exogenous origin. We will see examples for each subtype of them. As I mentioned, that the oxidative stress is a very general description of the imbalance of the redox status of the normal cells, and under such conditions, free radical level, I mean the pro-oxidants, among them the free radical level of the cells is increasing. Free radicals are of different types, can be carbon-centered radicals, nitrogen, oxygen, and sulfur-centered radicals. Each type of them can be formed even under physiological conditions. There are, however, pro-oxidants which are not non-radical, which has got non-radical character and formed in the living organisms, for example, hydrogen peroxide or hypochlorous acid or peroxynitrite, and of course transition metals that are also found in the living cells. Furthermore, there are some exogenous non-radical type oxidants, among them the singlet oxygen and the ozone should be mentioned. As for the reactive oxygen and nitrogen species frequently mentioned in the literature, here are the most important type of oxygen-centered and nitrogen-centered reactive species. Among them, we can distinguish radical type and non-radical type reactive particles. As for the reactive oxygen species, the non-radical hydrogen peroxide, hypochlorous acid, ozone, singlet oxygen, and peroxynitrite was already mentioned. And as for the radical type reactive oxygen species, among them we should mention the superoxide radical, the hydroxyl radical, which is the most reactive oxygen species formed under physiological conditions. The peroxyl, the alkoxyl, and the hydroperoxyl radicals are those which have to take into consideration when we are talking about this collective name of reactive oxygen derivatives. As for the reactive nitrogen species, among them we can find nitric oxide and nitrogen dioxide. Nitric oxide is an endogenous formed radical, I mean, can be formed even endogenous. And there are a lot of non-radical reactive nitrogen species. Part of them can be formed under physiological conditions. Some of them can be found in the environment that can also represent direct threat of of the living organisms. This big table summarizes the classification of antioxidants. Let's try to make it small units. When we are talking about antioxidants, we can distinguish natural antioxidants and synthetic antioxidants. The synthetic antioxidants like butyl hydroxy, toluene, EDTA, or the Clorox, are frequently used as antioxidant in foods, in pharmaceutical preparations, typically phenolic compounds or complex forming compounds, or the mix of them. As for the natural antioxidants, we can distinguish the enzymatic antioxidant and the non-enzymatic antioxidants. Among the latter one, we can see the vitamins, the carotenoids, the minerals, the polyphenols, and the quinones, and I do not repeat all of them I already mentioned. As for the enzymatic antioxidants, there are the primary enzymes which are responsible for eliminating the reactive oxygen species. For example, the superoxide dismutase. Superoxide dismutase, as you can see, is formed from oxygen in a way that oxygen gains one electron, and as a result, it remains only one unpaired electron, and at the same time carries a negative charge. Superoxide dismutase converts superoxide radical anion to oxygen, and when the concentrations are appropriate, the formed oxygen, I mean the oxygen present in the living organism, can be converted into hydrogen peroxide. So this is the two-step reaction in which superoxide dismutase convert the superoxide radical anion into hydrogen peroxide. Hydrogen peroxide itself is a non-radical oxidant. However, it becomes easily become to hydroxyl radical, which is, as I mentioned before, the most reactive oxygen-centered radical, with interaction with transition metals, copper and iron ions in particular. The elimination of hydrogen peroxide is managed under living organisms under physiological conditions by two enzymes. One of them is the catalase, the other one is the glutathione peroxidase. Catalase converts hydrogen peroxide to water and oxygen, and glutathione peroxide reduces hydrogen peroxide into water. At the same time, the reduced glutathione is oxidized to glutathione disulfide. So these are the enzymes, antioxidant enzymes, which are involved in elimination of the reactive oxygen species. As it's shown in this slide, the source, the endogenous sources of reactive oxygen species and the reactive nitrogen species is fairly wide. Among them, we should mention the mitochondria, the energy power center of the cells, in which oxygen radicals can be formed, and the endoplasmic reticulum, in which the the enzymes, for example, the cytochrome P450 enzymes, can generate oxygen radicals in the peroxisomes, the oxidases. I mean, that type of enzymes generate oxygen radicals, the myeloperoxidases in the phagocytes, just to mention the most important sources and most important sites of these reactive oxygen species inside the cell. And not to mention iron ions and copper ions, which are also involved in generation oxygen radicals because of their reversible redox properties. Elimination of endogenous peroxides can be managed by glutathione, reduced glutathione, as we can see. And here are two examples in more details how the living organisms at the expense of reduced glutathione can eliminate hydrogen peroxide and alkyl derivatives of hydrogen peroxides, so-called alkyl hydroperoxides. Reduced glutathione is a most important antioxidant in the cells. In most of the cells, the normal level of reduced glutathione falls into the millimolar range, which is relatively high under physiological conditions. And by means of some enzymes, for example, the glutathione peroxidase enzymes or the glutathione transferase enzymes, these hydroperoxides are reduced to the respective alcohols, non-toxic alcohols, and at the same time, the glutathione is oxidized to its disulfide derivative we call oxidized glutathione. The oxidized glutathione afterwards can be further reacts with protein SHs in so-called glutathionylation process and or reduced back by the glutathione reductase enzyme using a reduced form of NADP, NADPH, or NADH. Glutathione can eliminate not only oxygen radicals, however, glutathione can effectively eliminate so-called reactive electrophilic species. Electrophilic species are those typically carbon, but not necessarily carbon, containing centered derivatives, compounds, in which the carbon atoms are linked to high electronegative compounds, and that's why I have partial positive charge, or forms as a reactive intermediate with full positive charges. These electrophilic species in spontaneous reaction and or glutathione transferase catalyzed reaction can easily react with the reduced form of glutathione to form the corresponding adducts, which are glutathione adducts, which are typically less toxic than the reactant electrophile. The glutathione conjugates afterwards, however, are not stable. They undergo further metabolic transformation, and the fate of the glutathione conjugates in the body will be discussed in the next item of this series. As for flavonoids are very common, very well-known antioxidants, and the effectiveness is associated with different mechanism of actions. The flavonoids are phenolic compounds. Phenolic compounds with one or two, in some cases even more, hydroxyl groups directly linked to aromatic ring. The five most important mechanisms surveyed and discussed by two very good review articles are the hydrogen atom transfer mechanism, represented by this equation, in which the phenolic OH transfers one hydrogen atom, one electron and the hydrogen ion, to the radical, and that way converted it into a neutral species and forming an allyloxy radical, which is due to the delocalization is much more stable, much less toxic than the initial radical. In the second mechanism, the so-called single electron transfer mechanisms, the phenolic antioxidants transfer one electron to the radical. That way, the unpaired electron of the radical get paired. At the same time, the radical species, due to the extra electron, converted into an ion, and at the same time, the phenolic antioxidant again converted into a radical. Now it's a protonated form of the previous form, which are once again, due to the delocalization, represents a much more stable species than the original small atom molecule radical. The single electron transfer followed by proton transfer is a complex mechanism of the phenolic antioxidants. It's practically a combination of the previous two. In the first step, one electron is transferred to the aromatic phenol, and in the second step, the protonated allyloxy radical transfer the proton in the base, which is found in its surrounding. The sequential proton loss electron transfer, again a complex mechanism in which the deprotonated form of the phenolic antioxidants are formed with the radical, and in that way resulting in the protonated form of the radical and the allyloxy radical, which are formed in the first step, for example. Transition methylation is also a very important feature of the antioxidant effects of flavonoids, mostly the polyflavonoids, because the transition metals, among them iron and copper, as I mentioned before, are readily react with hydrogen peroxide. This reaction, which referred to as the Fenton reaction, results in hydroxyl radicals. However, if the phenolic antioxidants chelate these transition metals, that way reducing their reactivities towards hydrogen peroxide prevents the upper reaction, the Fenton type reaction with hydrogen peroxide, and that's why prevents formation of hydroxyl radicals. Here are two concrete examples. For example, that's quercetin as the compound forms complexes with metal ions, and here there is a two-step mechanisms of catechol derivatives with a radical, in which in the first case the radical abstract hydrogen atom to generate an oxygen-centered radical, and in the second step, the second hydroxyl also transfer one hydrogen atom, resulting in a quinone derivative of the original flavonoids, which also show electrophilic characters. However, the electrophilic character and strength and type of this quinone derivatives are very much different from that of the radicals, and which are smoothly react with glutathione, as I mentioned, as it was mentioned before, the general antioxidant and most important antioxidant in the living organisms. As for the chemistry-based classification, following the chemistry-based classification of the chemopreventive agents, among the initiation blocking agents, we can also mention the inhibitors of phase 1 metabolic activators, among them the cytochrome P450 inhibitors and the flavin monooxygenase inhibitors. And here we can also mention the sulfotransferase inhibitors and the N-acetyltransferase inhibitors. If you do not mind, I do not go into these details of specifying these enzymes, since the next lecture of this series will show details of the enzymes which are involved in transformation, chemical transformation of xenobiotics. Initiation blocking agents are also inhibitors of reactions, resulting in formation of reactive oxygen and nitrogen species. This reaction was already mentioned before, is the metabolic activation of dimethylbenzanthracene. Dimethylbenzanthracene per se is not reactive with cellular nucleophilic sites, because itself it's rich in electrons. However, the cytochrome P450 enzymes, among them the cytochrome P451 and 1A enzymes, can convert these compounds into a very reactive dihydroxy epoxy derivatives, and these dihydroxy epoxy derivatives are reactive electrophiles, which can react with we will see, it can react with glutathione in case of appropriate glutathione level in the cell. The other approach that inhibit the enzymes, inhibit the cytochrome P451A enzymes and prevent formation of the dihydroxy epoxides of the polycyclic aromatic hydrocarbons. Among the cytochrome P451A inhibitors, there are a lot of natural products, a lot of different classes of natural products. Among them, I wish to call your attention to the steel beans, the flavonoids, and the coumarins, which has got similar structural features. And as for among the flavonoids, chalcones and cyclic chalcone analogs, the methoxy derivatives in particular, are also among the very effective inhibitors of the cytochrome P451A enzymes. Another approach, other pathway of the chemistry-based classification of chemopreventive agents is induction of metabolic detoxification, which means that induction of phase 2, so-called phase 2 enzymes and other proteins, which can eliminate electrophilic species, which are typically formed as a result of metabolic transformation, as we see in the case of dimethylbenzanthracene. Among them, we can again mention the glutathione S transferase enzymes and the NADPH quinone reductase enzymes, among those others mentioned in the slide. As for the inducers of the NADPH dependent quinone reductases, research showed that among the inducers of these enzymes, we can find a lot of compounds which can readily react with chalcones. Those are the so-called Michael reaction activity of the chalcones. Why? Because because these enzymes possesses a reactive thiol function, and the reaction oxidation or alkylation of this thiol functionality of the enzyme results in induction, increase of its activity, and as a result, the increase of their capacity to eliminate toxic electrophilic species. Michael reaction of the thiols, okay, is that type of reaction in which the thiol, in this case we noted as Nu, representing, for example, the protein SH, reacts with a polar carbon-carbon double bond of an enone compound, which results through an enolic intermediate and a duct. What earlier was shown that the NADPH dependent quinone reductase activity, as you can see, which was found the highest in case of the chalcone analog 2-hydroxybenzylidene derivative, number 23, and that we see the higher, we could see the higher rate of the reaction of this enone with modal thiols, for example, glutathione, the higher the activity was found for the quinone reductase. So in this case, the authors got a indirect proof that the increase in the activity of the quinone reductase enzyme is associated with the reaction of the enone compound with the reactive cysteine function of the enzyme. Here are further data showing this approach. In this case, again, the compound number 23. This is the structure of the compounds, and you see the higher reactivity were associated with higher activity of the NQ-1 activity, which is now represented by the concentration of the enol, which needed to double the activity of the enzyme. Briefly, summarizing the present lecture, we could see that chalcones and flavonoids in general can act as effective chemopreventive agents through different mechanisms, among them the thiol reactivity and the hydroxy radical scavenging activity, plus the metallic complex forming activity of transition metals are the most important. Thank you very much for your attention.
Your microphone is mute. Okay. ¿Alguna pergunta para o professor? Bom, se não temos pergunta, então vamos dar até as 15 e 10 minutos. Vamos dar 20 minutos de parada, então 15 horas e 10 minutos vamos recomeçar com a parte número 4. Espero todos vocês aqui.